Now let's move on to our next segment, a privileged presentation on networks for AI, future state architectures. Joining us once again this year to deliver this presentation is Paresh Khatri, who is the Chief Technology Officer and Chief Architect for the IP Networks Division at Nokia. Paresh has more than 27 years of experience with both service providers and vendors in building carrier-grade IP MPLS networks, making him the perfect speaker to share this presentation with us. Ladies and gentlemen, please join me in warmly welcoming to the stage Paresh Khatri.
Thank you very much. Absolute pleasure to be here. The privilege, by the way, is all mine, right? That I can come up in front of you and spend a few minutes talking about my favorite topic these days, which is networks for AI. If you're working in the networking industry, AI does one of two things. Either your eyes glaze over when someone mentions AI, or they don't. So I was a little bit unsure about what to present here. If I speak about AI, I get that first reaction. If I don't speak about AI, then people think that we are out of touch. So I thought, okay, you know what, bite the bullet, speak a little bit about AI. But I want to put some context around this. What I will be discussing over the next, what is now 14 minutes, is the impact that AI will have on networks, and more importantly, how CSPs, our service providers, operators can really get into the value chain of AI. And this is particularly important, right? When you look at some of the major industry success stories and transitions that we've had over the past few decades, CSPs have not really got much out of it, right? The video revolution that saw content move completely to an online-based streaming mechanism was something that resulted in a lot of traffic over carrier networks, but really very little for them to gain out of it, right? So carriers have had to provide faster access networks, greater capacity in their core networks and so on to carry large amounts of video traffic, but they cannot actually easily monetize them, right? Most of the video that flows over our networks today is over the top. The second one, I would say, is the move to cloud, right? Cloud compute as well, where in the early days, operators tried to get into this with providing private clouds and hosting services and so on. But ultimately, once again, that was overtaken by the large hyperscalers. So we're at a point now where we have a similar sort of opportunity for service providers, which is AI and how to get into the mix. So I'll spend a bit of time talking about that. So I think it's pretty obvious to say AI is impacting our networks in a major way. Now, when we look at AI and the impact on networks, there's a few things we can think about. One is the use of AI to help us operate our networks, to build better networks, to get more efficient, and so on. The other one is really about the carriage of AI traffic, about supporting AI workloads, right? So our networks have to adapt to be able to carry that kind of traffic within our networks. And that is what I'll be focusing on over the next few minutes. Now, the first thing that, when I talk to operators out there, the first thing they ask me is, hey, what impact will AI have on network traffic? Now, we know that there's going to be some impact, but is it going to be a little bit of impact? Is it going to be a lot of impact? Is traffic going to double? To be honest, I don't think anyone really knows the answer to this, right? So at Nokia, we have Bell Labs. So Bell Labs Consulting did a study last year on the impact that AI will have on different types of traffic in the network. Now, I'm not going to go through this in too much detail, but the upshot here is that AI will be contributing an additional 25% of traffic from a CAGR perspective to all of our traffic carried in our wide area networks over the next 10 years, right? So ultimately in 2033, 2034, 33% of the traffic on networks will be as a result of AI. Now, there's also a very interesting thing that they did, right, when they did this analysis. They looked at AI traffic from a few different perspectives. One is what they're calling direct AI traffic. So this is the likes of You and me going on to, say, ChatGPT and doing a query or some sort of image generation tool and so on. So that's direct, where you are directly using an AI tool. That definitely adds to the amount of traffic in the network. But the greater amount of contribution of AI traffic will be what we call indirect AI traffic. So this is the result of AI happening in the back end, which may not even be visible to you. So it's a result of you using your normal tools that you use, your word processing tools, your image processing tools, video processing tools, and so on. But then it's doing some sort of AI processing in the background. And that will be the greatest contributor to traffic in the networks. So as a network operator, if you do nothing at all about AI, at least one thing you have to be cognizant of is the fact that it's going to hit you in terms of traffic. There's going to be a lot more traffic over your network, over and above what you're experiencing in terms of growth today. So that's one. Now, the more interesting thing for me is really where networking plays a part in AI and where it's different. So I've got a very high-level view of a network that is used to deliver generative AI, right? So there are three sort of aspects of this that I want to call out. Like on the left, you've got your ultimate users, your end users. On the right, you've got your large-scale data centers, right? So these are your hyperscalers and so on. And in the middle, you've got what we're calling edge or on-prem AI workloads or AI at the metro edge or the network edge kind of function. Now, the networking needs we have in each of these parts of the network are actually quite different. So if you look at the large-scale data centers that we have there, essentially what they're doing is doing a lot of training, right? So today, up till now, a lot of the AI traffic has been around training, building those foundational models. And that needs networking within the data center, what we call back-end networks that interconnect different GPUs so that they can work collectively to build these large language models. Now, in that environment, you need protocols that are very high bandwidth, that are lossless, and that are low latency. Now, the concept of lossless doesn't really exist in the public internet, right? We are used to loss. Our protocols run in a manner that reacts to loss in the network as well. So it's a very different networking paradigm. And so we've seen protocols like InfiniBand being used in that part of the network. There's been a lot more work being done recently to come up with Ethernet equivalents for that. So things like the Ultra Ethernet Consortium has come out with a alternative, or I should say enhancements to Ethernet that give us this lossless behavior that can be used in this part of the network. So that's what happens at those large hyperscale networks. But what is also happening is that we, as I'm sure you're all aware, that the big challenge here, the limiting point for us is the amount of power available at any particular data center. So what that means is that to run this training process, you need to spill over into other data centers because you just do not have enough power to be able to do that at a single data center. So that means that now we need this communication between data centers. Now, in the AI networking world, this is called scale across networking, where you're going across data centers, right? And it needs capabilities that are very similar to the networking technology that is used within a data center. So high bandwidth, low latency, very elastic kind of traffic flows, and so on. So that's within that sort of training environment. Now, what we see is over the next few years, what will happen is that the bulk of the flows or AI traffic will be generated as a result of inferencing. So using those models, right? And the trend that is happening out there is the move of these inferencing data centers to a point that is closer to the users. So edge data centers, right, is where this traffic will be actually served out of. And so you will need that interconnectivity between the training data centers and the inferencing data centers. And finally, the actual use of these models, right? So your end users accessing the AI models via whatever mechanism they have, right? So this is the whole inferencing process where you need that low latency communication between them. And what we're seeing here is that this is leading operators to now build different SLAs in the network. So the SLAs are moving from network-related SLAs to things such as, the time to first token, right? So the latency guarantees will be based on that instead of the raw, low-level network primitives that we are used to. So a lot of change happening there, right? Now, as I said, over the next few years, a lot of that the workload, AI workload, will be related to inferencing and not training. So it's going to move more and more towards the left. So I've already kind of spoken about it. I'll skip this. So in summary, I just want to sort of once again point out the 3 different areas of networking that are quite pertinent to AI. So firstly, it is what's happening within the data centers, right? So, and once again, this is the multi-tier thing. There's the communication that happens between GPUs that are part of a single system. There's communication between GPUs that are in different servers within the same rack. There's communication that happens between racks. And then you've got the communication that happens between data centers, the scale across networking, right, between them. And finally, and this is where it's really important for CSPs to really take note, it's the access and distribution networks that are part of network operators' networks, right, which allow connectivity of the end users to the actual inferencing servers that are in the cloud. So coming back to the point of getting into the value chain, right? Like I said, we missed the boat when it came to video. We kind of missed it. When I say we, I mean network operators. We missed the boat when it came to cloud compute. But here is a real opportunity. Because inferencing has to be close to users. It's gated by latency. Your latency has to be low, right? So that you can get responsive. And the hyperscalers do not really have the reach, right? They do not have the proximity to the end users, the relationship with the end users that telcos have. So the opportunity for the telcos is to really use that part of the network to get into the value chain. So as we, there are many, many examples of operators all around the world who are latching onto this, right? Trying to build some really interesting use cases. So what can you do, right? The dream for telcos over the last many, many years has been to not just be a dumb pipe provider. In fact, I hate the term, but it's used out there, right? I mean, there's nothing dumb about the pipes we provide. But there is a need to elevate that so that the perception is removed, right? That this is just providing like dumb, non-intelligent connectivity. So the idea is to really move from this model of just providing connectivity to becoming an AI solution provider, right? So what can operators do? There are a few different ways operators can play in this space. And they go from something that is very basic to something that is very advanced. And operators all around the world are doing precisely this. So there's various levels, like I said, right? So the key asset that operators have is your real estate, right? You've got your data centers, your central office sites, your exchange sites, whatever you want to call them. But you've got them. So you could just use the physical space, rent out the physical space. Okay, that's not very high value, but it's still something you could do. You can actually take it up a level and go, hey, I'll provide power, provide air conditioning, cooling and all that stuff. You could go one step further, convert it into some sort of data center, provide rack space. You could provide the actual bare metal, right? A platform as a service to be able to run these AI workloads on. Or you could go even further and actually provide AI services, right? So GPU as a service. So there are numerous examples of operators, particularly in the US and Europe, who are really, really leveraging this, right? They are taking advantage of the unique capability that they have, that proximity to the end users to be able to reduce that latency and not have to carry that traffic that I spoke about further in the network than it should. And that gives them that opportunity to really get into the value chain. So a few of the use cases, right, that we are looking at. So like I said, if you do nothing at all, the one thing that an operator can do and should do is to account for the capacity for AI, to position themselves as a preferred network for carriage of AI workloads, right, by having the capacity. Now that's very low level, but it's easily done without having to do too much in your network. You could go further, and you could go further by providing connectivity to your AI on-ramps. So secure, connectivity, reliable, low latency, services to all of this, together with SLAs that are tied to it, SLAs that are based on things like time to first token. It could go even further than that. You can go AI inferencing at the edge of the network, right? So repurpose some of these. One great example of a telco that's doing it is Telefonica in Spain. So what they're doing is they're taking some of their existing exchange sites, and they are repurposing them as AI data centers and cloud data centers, right, to really get into the value chain. And the final one that I wanted to sort of briefly talk about is the concept of sovereignty, right? This is becoming super important in today's world of geopolitics and so on. And so sovereignty, as far as data centers goes, is reasonably well known. But what an operator can do now is actually partner with sovereign cloud providers, or even build their own, and be able to provide this end-to-end connectivity. So it's not just the DC capability, but the secure access to it that ensures that the data stays within sovereign boundaries, but also the communication of that stays within the sovereign boundaries. So there's a lot we can do here, right? So what does that mean for networks? What that really means is, and this is one, I mean, I'm going to simplify this, but this could take like a few hours to describe. It's really about two things that I'm seeing, okay? Firstly is that we've got to look at our base network infrastructure that we use within the core of our networks. Today's networks are very statically defined, very manual, very rigid in architecture, use a plethora of technology. There's a lot of legacy technologies out there as well. So one of the things that operators are really doing here is this whole technology simplification, is to take this very bloated environment and come up with a simpler protocol stack, which you can do with what we have at our disposal now. The second area is around security. Security around things like DDoS, around quantum safe networks, quantum safe communication, because that's the other threat that is in the offing at the moment. And finally, about resiliency. And resiliency is something, once again, that is super critical, right? We talk about resiliency, but then if you look at if you look at the 10 largest network outages that have happened, they've all happened in the last 3 or 4 years. So while we've been running networks forever, we are still hitting issues with them, right, which takes out large parts of the network. So that's really important. And I'm going to speed up a little bit. The top one is actually super important, which is about now exposing the capabilities of the network so it can be easily consumed by other services, by applications, and so on. So today's networks are not really designed for that. So it needs a complete change of thinking, of paradigm, to be able to build networks that do that. Okay, so summarizing, I've tried to cover in 15 minutes what I normally spend 2 hours on, but I hope it gives you a bit of a feel for it. If you do want to know more details about this, please come and have a chat with us. So I'll summarize by saying that AI is having a huge impact on networks. What I talked about today was how networks need to change in order to be able to carry AI workloads. But then there's this other side of it as well, which is using AI to make networks smarter, more intelligent. Thank you very much.
Thank you very much, Paresh, for this informative talk on networks for AI. We're very glad to once again have you with us for this year. Now let's move on to our next privileged presentation by ETIX. At first, I understood that Pierre was going to be here and give the updates on data center trends, and I had a punchline for him too. I was going to call him a familiar voice and a handsome man. But instead, we now have our most beautiful Pauline Lahau, marketing manager at ETIX, to deliver these updates. Take it away, please. Thank you very much.
Thank you so much. Yeah, obviously it's not Pierre, but I will be handling it. So today we want to tease you about our presentation of tomorrow at 11. A little bit destroying, but I will be try to be clear about it. So as every year, we're doing a panel discussion tomorrow at 11 regarding data center trends. because data center is super linked to the connectivity. So as you know, everyone, Thailand is becoming a major data center market in Asia. That's narrative you heard everywhere in investor pitches, in BOI press release. But behind those announcements, behind what is the real question, we don't really answering that. So for the context, there is like a investment boom into Thailand market. BOI approval is booming. We also have hyperscalers committing billions of bahts. The EEC region is the bulk of region ambitions, but the gap is there between the announcement and what actually get delivered, between what's approval and what's operational. We don't know yet, and that gap is not only just construction delay, it's point to deeper structural question about these markets. So what we're gonna try to answer to the panel discussion is 4 booming topics. Is the supply real? There is significant difference between approval capacity and delivered capacity. Where is exactly the gap? What is causing the gap? Is it investment? Is it construction? Is it supply? We will try to answer this question. We also want to know who is filling this data center. Is it Thailand companies? Is it cloud? Is it AI? From one side, for sure, is hyperscaler, NCPs with no track record and no balance sheets on other. The risk profile for operators is very different, and the market is starting to feel it. Is the market has under external pressure? As we know, there is geopolitical risk, there is natural event, there is regulatory changes, and Thailand has been exposed to all these 3 in the past 12 months. So how the market is prepared about that. And finally, and I think is the most important regarding data center, can the infrastructure keep up regarding power, regarding water, regarding green energy? These are the real bottleneck and the headline that we never mention. So to debate all of this and to try to answer this question, we will have 4 speakers talking about data center trends tomorrow. On our side, ETIX, it will be Pierre, don't worry, not will be me tomorrow. He's gonna talk about the market overview and we'll do the moderation as usual. Kyle from GLL will talk about the investment and the real estate perspective, what the client needs, where they're looking for, is it EEC corridor, which type of investment there is behind. We will have Schneider Electric that will help us understand the infrastructure and also the technical constraint regarding supply, regarding also what is important in Thailand regarding infrastructure and everything that comes around. And Audrey from DFIDL for the legal and the regulatory framework. So we'll be happy to have you join tomorrow and to answer to all these questions. Thank you.
Thank you very much, Pauline, for sharing these valuable insights into the changing data center trend landscapes.